What if the sky itself was your first warning? What if the shapes of the clouds, the strange spirals above your head, or even the unsettling colors painted across the horizon could tell you that a storm of catastrophic power was on its way? And what if, long before meteorologists confirmed it, you could look upward and know from the sky alone that danger was near? For generations, communities living along coasts and in storm-prone regions have watched the heavens for signs of change. Long before satellites orbited Earth, before radar tracked swirling systems, people relied on their eyes. The transformations in cloud shape, the sudden deepening of the sky's colors, and the appearance of towering domes of clouds were nature's earliest warnings. Today, we have science to explain what those ancient observers saw, and research confirms what folklore long suggested. The sky tells the story of the storm. Clouds are not passive backdrops. They are dynamic indicators of atmospheric processes. Each form, from a wispy cirrus streak to a menacing cumulonimbus tower, reflects shifts in temperature, pressure, and moisture. During the birth and growth of hurricanes, typhoons, and other cyclones, clouds undergo dramatic changes. To the untrained eye, they might seem chaotic. To a practiced observer, or to meteorologists trained in tools like the Dvorak Technique, they are precise signatures of intensity, organization, and threat. One of the first visible changes occurs when high domes of clouds, what scientists call convective towers, begin to rise. These are not ordinary clouds drifting lazily across the sky. They surge upward, fueled by powerful updrafts of warm, moist air. From the ground, they appear as enormous cauliflower-shaped domes that climb higher and higher, dwarfing ordinary cumulus formations. Residents in Florida, the Philippines, or the Caribbean often speak of these cloud domes as the first sign something big is brewing. To meteorologists, they signal that deep convection is underway, an engine of potential cyclone formation. The NOAA Satellite Analysis Branch has spent decades studying how cloud structures evolve as storms intensify. Their data show that as tropical systems strengthen, the clouds at their core grow taller, thicker, and more symmetrical. On satellite images, these appear as cold, bright white areas because the cloud tops have reached such altitudes that they reflect maximum sunlight. But even without satellite data, an observer on the ground can sense the power in the sky. A cloud dome rising miles into the atmosphere, spreading into an anvil shape at its peak, is not a typical thunderstorm. It is a potential cyclone, gathering energy from the sea and atmosphere. Spiraling cloud structures offer another unmistakable clue. As storms organize, their convection no longer looks random. Instead, the clouds begin to wrap around a central axis, forming curved bands that spiral inward. This is where the human eye begins to see the storm's true shape, the swirl of a cyclone. From the ground, these curved bands may appear as long, arching streaks of clouds stretching across the horizon, subtly bending as if drawn into a giant wheel. Sailors of centuries past described these skies as clouds moving in a circle that no man could draw. Today, meteorologists know these spirals are not art but physics, air rotating around a low-pressure core, feeding energy into the storm. The Dvorak Technique, developed in the 1970s and still used today, relies heavily on analyzing these cloud top features. By measuring the symmetry of the spiral, the brightness of cloud tops, and the presence of eye features, analysts can estimate a storm's intensity even without direct measurements. But for those on the ground, the visual impression alone is striking. Spiraling convection clouds are nature's unmistakable handwriting, spelling out that a storm has organized and is preparing to intensify. Perhaps the most unsettling change, though, is not the shape of the clouds, but the transformation of the sky's color. Before a storm, the atmosphere often plays strange tricks with light. Skies that should be blue turn an ominous greenish hue. Sunsets become unnaturally red or purple, smeared with heavy cloud backdrops. Even at midday, the world can take on a dim, metallic tone, as if filtered through smoke. People who have experienced major hurricanes often recall these color changes as the most haunting memory, the moment when the familiar sky became alien. Science offers explanations. As thick clouds form and moisture fills the atmosphere, sunlight scatters differently. Shorter wavelengths, blues and greens, may dominate in unusual ways, giving the sky its sickly, unnatural tint. In other cases, dense moisture and dust in the air scatter red light, making sunsets look more violent than beautiful. For those who see it without scientific training, the effect is visceral. The sky feels wrong, and instinct whispers that something powerful is approaching. Historical accounts confirm how communities relied on these sky changes. In the Philippines, farmers would speak of the bruised sky before a typhoon, a purple or green cast that foretold violent winds. In Florida, fishermen knew that when cloud bands curved low across the horizon and the sky turned yellow-grey, a hurricane was not far. These observations, passed down through generations, align with modern satellite analysis. The human eye, when attuned to the sky, can detect patterns that instruments later confirm. The transformation of the sky is not limited to clouds and colors. The entire atmosphere takes on a different character. Light levels drop, sometimes hours before rain arrives. The sun may glow weakly through thick veils of cirrostratus, casting an eerie halo. At night, lightning flashes illuminate vast spirals of cloud that stretch across the horizon, revealing a scale far larger than ordinary storms. Even the air itself seems thicker, charged with humidity and tension. These sensory shifts, though subtle, combine with visual cues to create an unmistakable warning: the storm is near. Why does this matter today, when satellites and weather models can predict hurricanes days in advance? Because not everyone has immediate access to those tools. And even with technology, there are moments when power, internet, or communication fail. In those situations, the sky remains a universal warning system, available to anyone willing to look. Recognizing cloud domes, spirals, and unnatural colors can provide vital clues, even if official alerts are delayed. But there is another, deeper reason. Understanding the sky reconnects us to the natural rhythms that modern life has dulled. We often move through the world without noticing the heavens above us. Yet in times of crisis, survival may depend on rediscovering that awareness. To watch the clouds is not superstition. It is science visible to the naked eye. The NOAA studies remind us that storms are structured systems, and their clouds reflect their organization. The Dvorak Technique shows us that even without aircraft or direct sensors, trained eyes can gauge intensity from cloud features alone. For ordinary people, this knowledge translates into vigilance. A towering dome cloud, a spiraling band, or a sickly green sky is not just scenery, it is information. The challenge, of course, is interpretation. Not every strange sky means a hurricane. Ordinary thunderstorms also produce towering cumulonimbus and colorful sunsets. But the scale, persistence, and symmetry of pre-hurricane skies set them apart. Where a thunderstorm may tower briefly, a cyclone's clouds dominate the horizon for hours. Where ordinary storms scatter light in beautiful but fleeting ways, a hurricane's sky transformation lingers, spreading unease across entire regions. The key is not to panic at every unusual cloud, but to respect the signs when they appear in combination, especially during storm season. For those who have seen it, the memory never fades. Survivors of Hurricane Andrew in 1992 remember the sky turning an otherworldly shade, with massive domes of clouds stretching across Miami. Residents of Tacloban in the Philippines before Typhoon Haiyan in 2013 recall how the horizon bent into spiral cloud bands long before the winds hit. Each story reinforces the same lesson. The sky itself gives warnings, written in clouds and colors, visible to anyone willing to look upward. This is why recognizing changes in the sky should never be dismissed as folklore. It is a blend of lived experience and atmospheric science, a bridge between tradition and modern forecasting. When the high domes rise, when the spirals form, when the colors shift into unnatural hues, those are nature's signals. They do not mean safety. They mean prepare. Because the truth is simple. The sky is never silent before disaster. It speaks through shapes, through colors, through transformations that defy normality. The question is whether we pay attention. In the age of satellites, we sometimes forget to trust our own eyes. But when the sky itself begins to change, when clouds rise like mountains and the horizon curves into spirals, we should remember that the storm does not hide its arrival. It announces it, loudly, clearly, unmistakably, across the canvas of the heavens. So the next time you see towering domes pushing into the stratosphere, spiraling bands curling across the horizon, or an unnatural tint spreading across the sky, remember it is not coincidence, not imagination. it is the storm, revealing its face in the clouds. And those who learn to read that face may gain the time they need to survive. Imagine standing on a Florida beach in late August. The season is heavy with humidity, the waves seem restless, and the horizon looks different than usual. Instead of the bright, scattered cumulus clouds that normally drift in the afternoon, you see massive domes swelling higher and higher, pushing into the stratosphere. Their edges curl outward into anvils, spreading shadows across the land. The light turns dim, even though the sun has not yet set. To the experienced eye, this is not a normal thunderstorm. It is the sky warning of something far larger, a hurricane taking shape offshore. This kind of scene has been described repeatedly in places where hurricanes strike. Florida's long history with these storms has left behind countless records of unusual skies. Before Hurricane Andrew struck in 1992, residents reported towering cloud masses dominating the southern horizon, spiraling bands visible even without satellite images. The air was still hot and heavy, but the sheer size of the cloud structures gave away the storm's power. The NOAA Satellite Analysis Branch later confirmed how Andrew's cloud tops reached extreme altitudes, registering some of the coldest readings in satellite archives at the time. What Floridians had seen with their eyes, unusually massive domes and spirals, was validated by satellite science. In the Philippines, survivors of Typhoon Haiyan in 2013 tell similar stories. Days before landfall, the skies had already begun to change. Farmers noticed towering convective clouds that seemed endless, stretching across the horizon. By the eve of landfall, spiraling bands of clouds curved ominously, visible even to rural villagers without access to radar or television. More hauntingly, many remembered how the colors of the sky grew strange. A greenish cast hung over the fields, and sunsets burned an unnatural red. These details, once dismissed as folklore, matched scientific understanding. High moisture content, thick cirrus canopies, and scattering of sunlight created colors that ordinary weather never produces. NOAA's Satellite Analysis Branch explains that storm intensity can be judged by the organization of clouds. Weak systems appear ragged, with clouds scattered unevenly. But as a storm intensifies, its clouds grow more symmetrical, spiraling in tight curves. From the ground, this symmetry appears as consistent arcs stretching across the horizon, bands that wrap around a hidden core. To the human observer, the difference is striking. Random thunderstorms look chaotic, but a hurricane sky looks purposeful, as though the clouds are following an invisible design. That design is the physics of rotation and pressure, organizing chaos into a lethal system. The Dvorak Technique, first developed by Dvorak in 1974, remains a cornerstone of storm analysis. Its brilliance lies in translating visual features of clouds into numerical intensity estimates. Analysts look at cloud top temperatures, spiral curvature, and the presence of eye-like features to assign a T number that corresponds to storm strength. While satellites provide the images, the method itself is based on what the human eye can discern: patterns of shape, brightness, and symmetry. In many ways, the Dvorak Technique is a modern scientific version of what fishermen, farmers, and sailors have done for centuries, reading the sky for signs of the storm. One fascinating aspect of the Dvorak method is its reliance on cloud brightness in infrared imagery. Stronger storms push their cloud tops higher into the atmosphere, where they cool dramatically. Cold clouds appear bright white on infrared satellite images. To analysts, the whiter the cloud, the stronger the convection. To someone standing on the ground, these same clouds appear as towering, dense masses that block sunlight and loom like mountains in the sky. The connection is direct. What satellites measure in numbers, humans can see as visual domination of the horizon. Case studies illustrate how these signals appear in real life. Before Hurricane Katrina made landfall in 2005, residents of New Orleans and the Gulf Coast described unusual skies in the days prior. High cirrus bands streaked across the sky in broad arcs, connected to the outer structure of the storm. By the night before landfall, towering anvils stretched so far overhead that lightning illuminated massive structures across the entire horizon. To ordinary citizens, the skies felt apocalyptic. To scientists, they were textbook signs of a rapidly intensifying storm. In Japan, before Typhoon Vera struck in 1959, eyewitness accounts describe clouds like spirals of smoke, visible from Nagoya. Farmers noticed bands curving across the horizon, not dissipating like ordinary clouds, but tightening with each passing hour. Meteorologists analyzing satellite imagery decades later confirmed the accuracy of these descriptions. The spiral bands were indeed pulling inward, feeding a core that would become one of the most destructive typhoons in Japanese history. What unites all of these stories is the universality of human perception. Across cultures and centuries, people describe the same features: high domes of convection, spiraling bands, and unnatural colors. Today, these features are backed by NOAA's data and the Dvorak Technique. But long before instruments existed, humans were already skilled at identifying these signals. The difference now is precision. Instead of saying, "the sky looks wrong," we can say, "cloud tops are reaching -80 degrees Celsius, indicating explosive convection." Both statements describe the same truth, one poetic, the other scientific. The physics behind these sky changes deepens our understanding. Convective domes form because warm, moist air rises rapidly from the ocean's surface, condensing into towering cumulonimbus clouds. As the storm intensifies, these clouds merge into massive clusters, their tops flattening into anvils when they hit the tropopause. Spiral bands form because the rotating low-pressure system organizes convection into curved lines, each feeding the central vortex. The strange colors come from light scattering through dense moisture and ice crystals, bending wavelengths into eerie greens, reds, or purples. To the human eye, the result is unsettling. To the scientist, it is predictable. And yet, even with this knowledge, the danger of misinterpretation remains. Ordinary people sometimes mistake these skies for ordinary thunderstorms, underestimating the storm's approach. Others overinterpret minor cloud changes, creating unnecessary panic. The challenge is not only to observe, but to understand context: storm season, forecast data, and the scale of what is seen. Recognizing the difference between a tall thunderstorm and a hurricane's convective dome can save lives, but it requires awareness and education. This is why public education is essential. In coastal communities, teaching people to recognize sky transformations can complement official forecasts. A fisherman who sees spiral bands curving across the horizon may head to port even if he has no radio. A farmer who notices green skies and towering anvils may secure his fields before landfall. These decisions, rooted in observation, can reduce vulnerability. And in regions where communication infrastructure is weak, the sky itself remains a vital tool for survival. Technology, of course, continues to refine our vision. Today, satellites provide real-time images of cloud structures, allowing analysts to apply the Dvorak Technique globally. But even these tools rely on the same visual features humans notice with their eyes: shape, symmetry, brightness. The difference is scale and accuracy. Where one villager sees spirals above the horizon, a satellite sees the entire cyclone spinning across hundreds of miles. Yet both are observing the same truth. In the end, the lesson is simple. The sky does not lie. Its transformations, towering domes, spiraling clouds, and unnatural colors are reliable signals of storm development. They are the language of the atmosphere, visible to anyone who takes the time to look. Modern science has given us new ways to interpret that language, but the fundamentals remain the same. Because when a storm approaches, the sky changes first. Long before winds howl or rains flood, the warning is written above us. To ignore those signs is to forget the wisdom of centuries and the science of today. To recognize them is to honor both tradition and research, and perhaps to survive. The sky above us is more than a backdrop. It is a stage where the drama of storms begins. Across the world, from the Gulf of Mexico to the Philippine Sea, from the Caribbean to the coastlines of Japan, people have learned to read the changes in the sky as early warnings of disaster. The lesson is consistent. Before a hurricane or typhoon makes landfall, the heavens transform in ways that are as unmistakable as they are unsettling. Global comparisons reveal how universal these transformations are. In the Caribbean, fishermen speak of skies that turn the color of bruises before a hurricane, deep purples and greens that feel heavy and unnatural. In the Philippines, villagers talk about cloud walls that rise like mountains, marking the approach of a typhoon. In Florida, coastal residents recall how long, spiraling cloud bands stretched across the entire horizon before storms like Andrew and Irma struck. And in Japan, survivors of Typhoon Vera and other powerful storms described clouds curling in arcs that seemed to pull the entire sky into a vortex. Different cultures, different languages, but the same observations. Towering domes, spiraling shapes, and strange colors. Science validates these lived experiences. The NOAA Satellite Analysis Branch shows how intensifying storms produce towering cumulonimbus domes that reach extreme altitudes, often exceeding 50,000 feet. These clouds, capped by flat anvils, are not isolated. They cluster into massive formations that dominate the sky. The Dvorak Technique provides a structured way to interpret these clouds, translating their symmetry, curvature, and brightness into estimates of storm strength. For example, when spiral bands are tightly wound and the central cloud mass appears symmetrical, the storm is likely intensifying rapidly. What the eye sees as organized clouds is, in fact, the visual evidence of rising wind speeds and dropping central pressure. Color shifts in the sky, often the most haunting memory for survivors, also have scientific roots. Light scattering through dense moisture and ice creates unusual hues. A green sky, for instance, often occurs when sunlight refracts through water-heavy clouds, a signal of severe convection. Red and purple skies at unusual times of day happen because thick cirrus anvils filter sunlight, bending longer wavelengths toward the eye. Even metallic or grey-yellow tones can result when moisture and aerosols fill the air, muting natural colors. To the human brain, these shifts feel wrong because they break expectation. We're accustomed to predictable blue skies, golden sunsets, and natural transitions. A hurricane sky violates these norms, signaling that the atmosphere is under extraordinary strain. Beyond shapes and colors, the atmosphere also changes in texture and character. Light grows dim, even at midday, as thick canopies of cirrostratus spread overhead. At night, lightning illuminates cloud spirals that seem to stretch endlessly across the horizon. The world feels both close and infinite, as if the storm is collapsing the boundary between earth and sky. Survivors often describe these moments as surreal, almost dreamlike, because the familiar order of the heavens has dissolved into something vast and threatening. History is filled with testimonies of people who misread or ignored these signals. In some cases, villagers assumed that the unusual sky was simply a beautiful sunset or an ordinary thunderstorm. Hours later, the true storm arrived with devastating force. In other cases, the sky's warnings spurred communities into action. In the Philippines, stories tell of families securing homes and animals after seeing spiraling cloud bands. In Florida, seasoned fishermen knew to return to port when the horizon filled with towering cloud domes. These decisions, rooted in sky watching, often made the difference between safety and disaster. Modern forecasting has revolutionized storm preparedness, but sky changes remain relevant. Satellites and models can predict storms days in advance, yet power outages, damaged infrastructure, or lack of access can cut people off from official updates. In those moments, the sky itself is the last remaining tool. A farmer who notices unnatural colors, a fisherman who sees spiral bands, or a resident who watches towering domes rise higher than ever before may gain precious hours of preparation. Knowledge of the sky is not a replacement for technology, but it is a vital complement. The physics behind cloud spirals further reinforces their role as warning signs. Hurricanes are rotating heat engines. Warm ocean water fuels rising air, which condenses into towering convection. As the system organizes, the Coriolis effect bends these rising columns into spirals, wrapping them around a central core. From space, the result is a perfect swirl. From the ground, it appears as long, curved bands stretching across the sky. These spirals are not decoration. They are the arteries of the storm, carrying energy inward and power outward. To see them is to see the storm's skeleton, written in cloud. Equally important are the cloud domes, or hot towers that shoot into the upper atmosphere. Research shows that these intense convective bursts often precede rapid intensification of hurricanes. When residents on the ground notice cloud towers that seem taller and more massive than ordinary storms, they are witnessing the storm strengthening in real time. These are the clouds that tell meteorologists a cyclone may leap from Category 2 to Category 4 within hours. And for those on shore, they are the most visible sign that time is running short. The challenge lies in interpretation. A thunderstorm also produces tall clouds, spirals, and vivid colors. The key difference is scale and persistence. A thunderstorm tower may dominate one corner of the sky, but a hurricane canopy covers the horizon. Spiral bands in thunderstorms are localized. In hurricanes, they stretch for hundreds of miles. Color changes during a thunderstorm are fleeting. In a cyclone, they linger, casting entire days in unnatural hues. Learning to tell the difference is not instinctive. It must be taught. This is why both science and public education are essential. Globally, there is a renewed effort to integrate indigenous knowledge with meteorological science. Fishermen, farmers, and elders have preserved oral traditions of skywatching that align closely with NOAA's data. By validating these traditions with modern research, scientists hope to build trust and expand resilience. When people see that their ancestors' wisdom is consistent with satellite analysis, they are more likely to act on warnings. In this way, the sky becomes not just a scientific subject but a cultural bridge between past and present. Ultimately, the changes in the sky before a storm are both a scientific reality and a human experience. They remind us that the atmosphere is not abstract. It is visible, tangible, and communicative. Clouds rise, spirals form, colors shift, and the world above us speaks. Whether we listen can determine whether we survive. The conclusion is clear. Never dismiss strange skies. Towering domes, spiraling bands, and eerie colors are not coincidences. They are the atmosphere revealing that a storm is near and strong. In the past, ignoring these signs has cost lives. In the future, recognizing them may save them. So the next time you stand beneath a sky that feels wrong, when clouds rise like mountains, when spirals stretch across the horizon, when the light turns green or purple, remember this: the storm is speaking. The question is whether you will listen. At Crisis Lens, we explore the hidden truths of disasters, the science behind survival, and the stories that matter when nature turns violent. Subscribe now, share this video, and turn on notifications. The next storm will come, the sky will change, and by learning to read it, you may find the warning you need.